Hello and welcome everybody. These classes are chemistry unlocked classes. Let me tell you what will be taking place in these classes. As you all can see, this is chapter 1, CBSE board NCERT textbook, chapter 1 of class 9th chemistry. So in these classes, we will be discussing about the chapters, chemistry chapters, majorly one by one. To start with chapter 1, matter in our surroundings. Children, what I will be doing is that you all study in school, but some children need some extra hand holding after they come from school. Like the child was not able to understand, let's say, activity 1, what was the aim of the activity? Similarly, what was the aim of activity 1.1.2? So I'll be discussing these activities with you all. Also, I will be using this AI tool to, let's say, present in front of you the summary of the chapter, right? So we'll be using some AI tools to understand the chapter better. Again, chemistry unlocked classes. So let me present it in a sample form. Let's say we are discussing chapter number 1. So as you all can see, I'm presenting in front of you the infographics of the chapter. So this is a picture method or a picture which will be describing you what all is discussed in the chapter or what all this chapter talks about. Again, chapter number 1, matter and its surroundings. So children, as you can see my infographics, you can very well see that the chapter would be, first of all, we'll be talking about what is matter. So matter, you all know, is anything which occupies space and has mass. So the chapter will be talking about matter has mass and volume. So anything which has mass and occupies space is called as matter. Then there was a quest that is matter a particle? Does it have a particle nature or is it continuous like a wooden block? So there are certain activities in the chapter like KMNO4 activity. So we'll be discussing about it, that how does that activity prove that matter is having a particulate nature and not is continuous in form. Then there's a relation established in the textbook, relation between kinetic energy and temperature, as this picture is telling you very clearly that when we increase the temperature, like this was the beginning. So when we increase the temperature, the kinetic energy in the movement of the particles, they increase. Then this is what is the kinetic molecular theory, which defines matter according to its particles. So as you know, till now that solids have a definite shape and definite volume, liquids have a definite volume but no definite shape. So we'll be diving deep into the particle form of the matter, and we'll see that how these particles decide the properties of solids, liquids, and gases. So as the picture is showing you that solids, the particles are compactly packed. They are not moving from one place to another. They just vibrate at their places. Whereas in liquids, the movement is slightly more than solids. So they are free to move in the container. That is why liquids have a definite, but they don't leave the container. So that is why liquids have a definite volume, but they don't have a definite shape. Whereas in gases, as you can see, the particulate movement is maximum. They can easily leave the container. Hence, gases don't have, neither they have definite shape nor they have a definite volume. Then you have something which is being discussed in the chapter that is about latent heat. So suppose I am melting ice. Now, if you put a thermometer in the container containing ice, so although it is kept outside in the room or even if you are heating it, what will happen is you won't see the temperature rising beyond 0 degrees until all the ice is melted and is converted into water. So this is called as the latent heat. That means the heat is here being used to convert all the ice into, it's breaking the bonds between the or interparticular forces between the ice molecules, that is water molecules in the solid state. And when all the forces are broken, then the temperature starts rising. Same thing happens at 100 degrees when water is boiling. So the temperature seems to be fixed over there until and unless all the water is converted into water vapor. Then you have interstate conversions. So some conversions are shown in the picture: sublimation, deposition, evaporation. So what happens at the particle level and liquefaction. So that will be discussed in the chapter. So this is the infographics. Now also let me present in front of you, before we go to a journey, we should have a map with us. So let me present with you with you the map of, or the mental map, or what do we call it, mind map, in front of you before we delve into the chapter. Now this is the entire map or entire journey which we'll be taking. So matter in our surroundings, it's the name of the chapter. First we'll define matter. So as you can see, the definition of matter is occupies space. It has mass, and examples are air, food, stones. Anything which has mass and occupies space is defined as a matter. Then let's see what else will be discussed in that. So there again, in the previous history, there was a quest whether the matter has a particulate nature or it is continuous. So yes, matter has a particulate nature. The particles are very small. Again, KMNO4 activity will be used for that. So when I'll discuss the chapter, I'll explain it to you. And the particles are in continuous motion. Again, there's an activity related to it, that what happens to the incense stick, why does perfume travel from one corner to the other corner of the room. So this proves that particles of matter have continuous movement. Then you have characteristics of particles. So once it was proved by kinetic molecular theory that all matter is made up of particles, then other postulates or other properties were discussed or were found, and which came as the other postulates of kinetic molecular theory. First was that all the matter, be it the matter of solids, liquids, or gases, all the particles, they have spaces between them. It is called as interparticle space. Then they are continuously moving, and movement, the energy which is included, or which is based on movement, is called as kinetic energy. So all the particles, be it solids, liquids, or gases, they have kinetic energy. We'll compare the kinetic energies of solids with liquids and gases, and so on. Then they have interparticle attractions. They attract each other, and something called as diffusion. So again, some activities related to it. States of matter. So you all know solids, liquids, and gases. Let's see the properties of solids. So you all know solids have a definite shape. They have fixed volume. They are rigid and incompressible. Again, we'll see how we can connect it through the particular arrangement. Liquids, they don't have any fixed shape, but they have fixed volume, and they are fluid. That means they move from one place to another. Gases, on the other hand, they don't have any fixed shape or volume. They are highly compressible. Again, we'll connect it to the large interparticle spaces in gases, and they diffuse fast. That means they intermix with each other very fast. Then you have something called as change of state or interconversion of matter. So we can change solids into liquids, liquids into gases. So what is the effect? How can we convert it? So by changing the temperature, by changing the pressure, or some direct changes. So let's see what is the effect of temperature. So for example, melting and boiling. Melting is also called as fusion. Boiling is also called as vaporization. So when you change the heat, or when you heat a substance, you encounter or you see the processes like melting and boiling. Something related to latent heat, as I told you previously also. Then effect of pressure, so compression of gases. So for example, LPG cylinder which we have, so here it is called as liquefied petroleum gas. So if you want to liquefy a gas, you need to increase the pressure and decrease the temperature. So this is called as compression of gases. And when you say take carbon dioxide gas and put a lot of pressure onto it and decrease the temperature, it converts into solid carbon dioxide, which is dry ice. And then what are the direct changes? So sublimation, like camphor, you have naphthalene balls. So they directly change from solid to gas without passing through the liquid state. So this is direct change. And deposition, that is the vice versa, that if you take camphor vapors and cool them down, they will directly go into the solid state. So this was my introductory video, children. So I told you that what all you will be studying in the chemistry unlocked classes. In my upcoming video, we'll be going through this chapter. So I will be talking about the main points of the chapter, that is the activities, as I told you. So I'll be decoding all the activities, how they are related, what is the aim, what is the observation, what are the conclusions of the activities. And then I will also be going through these questions so that if you have any problem, any doubt in this, so you can listen to my video and listen to my solutions. And finally, I would be discussing the chapter, I would be discussing the textbook exercises which are at the back. So tell me, how did you like this idea? If you have anything else to convey, like any other help if you want, please let me know in the chat box. So see you in the upcoming classes. Goodbye, children.